We are in this section are trying to find out information about the zeros of our functions. Now, Descartes' rule of signs does not tell us what zeros we will get or how to find them, but it does tell us what we should be looking for. How many positive zeros, or how many are the zeros are negative, or how many of them are complex. Now, Descartes' rule of signs says the number of positive roots is equal to or less than by increments of 2 to the number of sign changes. So you count how many times it changes from positive to negative, could be equal to that, or you could go down by increments of 2, by subtracting 2 until you get down to 0. Well, same type of thing with negative roots. The number of negative roots is equal to the number of sign changes, or the number of increments that you go down by 2's after you go ahead and plug in a negative x and then simplify it down. So, for looking at Descartes' rule of signs here for this one here, we need to go ahead and count our sign changes. Your positive sign changes, you just count your original problem. Here you're positive, you're going to negative, so that's a sign change. Here you're positive or negative and you're going to positive, so that's another sign change. Here you're positive and staying positive, so you don't change signs. But here you're positive going to negative. So the number of positive roots is 3, or remember you can go down by increments of 2. So you go down by 2 again and you get 1. Now, we know that we can't go down by 2 again because that would give us a negative 1. And we can't have a negative number of possibilities. And Descartes' rule of signs is talking about the possibilities. Now, when you're looking for your negatives, you need to go ahead and plug in up here. It says a negative x. So I'm going to go to my original function, replace all my x's with a negative x. Then all we have to do is simplify. Here we have a negative to an odd power, which you know changes your sign in front. The next one here we have a negative to an odd power. It's going to change that in front. Here we have an even, or a negative to an even power, not going to change your sign in front. Here you have a negative to an odd power, going to change your sign in front. So now we need to count our sign changes. We're starting out negative, we're going to positive. That's a sign change. Here you're positive, saying positive, no sign change. But here you're positive going to negative, that's a sign change. Last year you're both negative, no sign change. So we have 2 sign changes. So you could have 2 negative roots. But once again, you could go down by increments of 2. If we go down by 2 again, that would give us 0. Well, it is possible you could have a 0 possibilities. But we're not going to go down by 2 from your 0 because that was, once again, gives us a negative number of possibilities. So, when you're looking at your positives, you could have 3 or you could have 1. But when you're talking about that, your positive 3 here could be paired up with the 2 for the negative. Or your positive 3 here could be paired up with the 0 for the negatives. Same idea for your 1. Your 1 here could be paired up with the 2. Or your 1 here could be paired up with the 0. But how does that help us figure out the complex? Well, remember, the number of roots from this one up here is always your highest degree, which is 5. And your positive roots, your negative roots, and your complex roots always have to add up to then that 5. Well, 3 plus 2 is going to be 5 already, so you can't have any complex. So when you add across here, it has to add up to 5, so you know the complex would have to be 2. So when you add across here, it has to add up to 5 because that's your highest exponent, so this would have to be 2. Same idea in the bottom one, so we would get 4. Now we want to talk about your upper bound and your lower bound. Your upper bound is a number that's larger than any of your zeros. So if you go ahead and you do your division, everything you get out from your division, synthetic typically, is going to be greater than or equal to 0. A is a lower bound, meaning something that's smaller than any of your zeros, if what you get out alternates in sign. Now, the two theorems up here at the top, the upper and the lower, are helpful in setting your calculator window. There's another one that's not nearly as precise that is also helpful in setting your window. I refer to it as your M&M theorem. You take your largest leading coefficient or your largest coefficient or constant and the absolute value of that. So it could be a negative. So we're talking largest meaning size, not with the sign in front, over the absolute value of your leading coefficient. We divide those two and add 1. And the M&M theorem says all your roots have to occur between positive m and negative m. So let's go ahead and find your upper and lower bounds based on what we were just dealing with. So to find your upper bound, start with your first positive number of 1. If that works, great. If it doesn't, then you try the next number up 2 and so on. So synthetic division. So we're going to start with 1, put 1 in the half box. Then we're going to go ahead and put these numbers from this afterwards. Remember, you always drop down, you add down, you get 2, you multiply, you add down, you get a negative 3. But once again, we're looking for an upper bound. Everything we get out has to be positive. We're not getting everything out to be positive, so there's no need to even finish the problem. So then we're going to, instead of trying 1, we're now, since we know it doesn't work, we're going to try 2. Add the 2 down, take your 2 times your 2, you get 4. Negative 4, or negative 5 plus 4 is negative 1. Well, once again, we're looking for an upper bound. Everything we get out has to be greater than or equal to 0. We don't have that, so we don't even need to work it farther yet. So we'll just stop. So the 1 and the 2 don't work because not everything you're getting out is greater than or equal to 0. So we'll go ahead and try the next number up of 3. So you take your 2, bring it down, multiply by 3, get 6, bring it down, we add, get 1. Hey, we got by that trouble spot that's been bothering us before, our 3 times our 1. We add down, our 3 times our negative 7, or our 3 times our 7 is 21. We add down. So everything we get out is positive. Since everything you get out is positive, that means 3 is a upper bound. It is not the low upper bound, because we don't know for sure if it's not 2.5 or 2 3/4. We just know 3 happens to be an upper bound, but not necessarily the. It just happens to be the first natural number that works for us. When you're looking for a lower bound, you want to go ahead and start with your first negative number. Well, that would be negative 1. And you want to do synthetic. Add down, you multiply, you add down. Remember, for it to be a lower bound, these signs need to alternate, and we're positives and negatives, so we are alternating. Then you multiply, you add, we're still alternating. We multiply, we add, we alternated all the way, so that means that negative 1 is a lower bound.